Now let's move inside the cockpit and take a look at the flight instruments and the rest of the airplane panel. Most training airplanes have fully functional dual controls and can be flown from either side. Traditionally, the pilot flies the airplane from the left.
The instrument panel is roughly divided into three areas. On the left are the flight, navigation, and engine instruments, electrical switches, and circuit breakers. The radios, engine controls, fuel controls, flaps, and trim are positioned in the middle within reach of either pilot. On the right are the cabin environment controls, hour meter, and space for options. The flight instruments are the airspeed indicator, the attitude indicator, altimeter, vertical speed indicator, turn coordinator, and heading indicator, also called the directional gyro. The airspeed indicator is marked in nautical miles per hour, called knots for short. Knots are a measure of speed based on nautical or sea miles. Aviation uses both nautical and statute miles for measuring distances and speeds. A nautical mile is 6,076.1 feet. The decimal can be dropped and still be reasonably accurate. A statute mile is 5,280 feet. A nautical mile equals 1.15 statute miles. For example, 10 nautical miles equals 11.5 statute miles.
We normally say that the airspeed indicator measures the speed of the aircraft through the air. However, it's also correct to say that airspeed is the speed at which the air is flowing over the airplane.
The speed ranges and limitations marked on the airspeed indicator are for the make and model airplane in which the indicator is installed. Different makes and models of airplanes will have the markings at different speeds. The speed marked by the red line should never be exceeded. You should only fly at airspeeds in the yellow arc in smooth air. The green arc denotes the normal operating airspeed range. The white arc is the flaps operating range, and the two windows are used in determining true airspeed, which you'll find out about later. Rate of climb or descent in feet per minute is measured by the vertical speed indicator, and the altimeter measures the altitude or height of the airplane above sea level. An altimeter has three hands, just like a clock. The fastest moving hand, which looks like a minute hand, is the hundreds of feet hand. The shorthand reads in thousands of feet, and the longest hand, which moves the slowest, indicates tens of thousands of feet. Let's try reading some altimeter indications. This altimeter shows no tens of thousands of feet, no thousands of feet, and the hundreds of feet hand is between 800 and 900 feet. Each of the lines between 800 and 900 feet represents 20 feet. The altimeter shows 840 feet. Let's see what an altimeter would show at the highest airport in the United States. The tens of thousands of feet hand shows almost 10,000 feet. The thousands of feet hand shows almost 10,000 feet, and the hundreds of feet hand shows about 930 feet. The altimeter indicates 9,930 feet. Leadville Lake County Airport in Colorado is 9,927 feet above sea level. The traffic pattern altitude at Leadville is 800 feet above the airport. At traffic pattern altitude, the altimeter shows 10,727 feet. Let's go to the other extreme. Calipatria Municipal Airport in California is 180 feet below sea level. This altimeter shows either 180 feet below sea level or 99,820 feet. Knowing that the altimeter isn't in a spacecraft lets you decide that 180 feet below sea level is the correct indication. On some altimeters, the tens of thousands of feet hand is the shortest hand. Let's look at the altitudes we discussed using this altimeter. Here's 840 feet, 9,927 feet, and 10,727 feet. And lastly, 180 feet below sea level. Since the altimeter reading is based on barometric pressure, and barometric pressure is constantly changing, the altimeter must be set prior to every flight. The attitude indicator uses a gyroscope to stabilize a horizon bar, which stays parallel to the natural horizon. The miniature airplane pitches and banks around the horizon bar the same way your training airplane pitches and banks around the natural horizon. Earlier names for this instrument, which might be more descriptive, were the artificial horizon and the gyro horizon.
The magnetic compass is located away from metal and electrical wiring to reduce the effect of local magnetic fields.
The lubber line shows the direction the airplane is pointing. The lubber line, instrument case, and the airplane move around the compass card, which remains oriented to magnetic north. Compass accuracy is also affected by turns, banks, and speed changes. So the heading indicator is the principal direction instrument used in flight because the heading indicator is gyroscopically stabilized. It's not affected by banks, turns, and speed changes. However, the heading indicator isn't a compass and must be set to the compass indication before takeoff and periodically adjusted to the compass indication while the airplane is in steady, level flight. Another gyroscopic instrument, the turn coordinator, gives us information about the direction and rate of the turn. The ball or inclinometer, which is under the turn coordinator, shows the quality of the turn based on proper balance of the forces on the airplane. If everything is balanced, the ball will remain centered during a turn. The power setting is shown on the tachometer, which shows the revolutions per minute of the engine, and it's marked to indicate the maximum permissible RPM of the engine.
The engine controls begin with the throttle, which is like the accelerator pedal on a car. Push forward to open the throttle and increase power, pull back to close the throttle and decrease power. The throttle friction lock adjusts the ease with which the throttle can be moved. The airplane engine has a mixture control to regulate the ratio of gasoline to air entering the fuel distribution system. Push forward to increase or enrich. Pull back to lean or decrease the amount of fuel in relationship to the amount of air.
Engine instruments and gauges are marked with green to show normal indications and red for abnormal indications. The oil pressure and temperature gauges are used to monitor engine operation, and the fuel flow gauge, as you probably suspect, monitors fuel flow in gallons per hour. Near the fuel flow gauge is an exhaust gas temperature gauge, which gets its reading from a thermocouple probe in the exhaust stack. Exhaust gas temperature is useful in helping the pilot set the mixture. Some electric items have switches and are all protected by circuit breakers. The flap control has detents at the 10 and 20 degree positions. All the way down is 30 degrees flap deflection. A scale pointer to the left shows you flap travel in degrees. The elevator trim control wheel is rotated forward for nose down trim, aft for nose up trim. The trim position indicator is to the left. The gyroscopes in the attitude indicator and the heading indicator are usually driven by air pressure. The vacuum gauge enables the pilot to check the operation of the two engine-driven vacuum pumps. Fuel gauges show the approximate amount of fuel in the tanks. The fuel selector allows the pilot to draw fuel from both tanks simultaneously or either tank individually. There's a separate fuel shutoff valve. Finally, there's a combination voltmeter, clock, and outside air temperature gauge. This will become more important later in your training as you delve deeper into discussing navigation and weather.
This finishes our look at the instruments and panel of a typical training airplane. It's a great idea to just spend some time on your own, sitting in the airplane, learning the position of the switches and the instruments and the gauges. This will really pay off. You'll be able to concentrate on flying the airplane because you will already be familiar with the cockpit and the instrument panel. Spend some time getting to know your airplane. It will be time well spent.